This is going to be a cybersecurity architecture tutorial video where I walk you through how I architected and designed an actual product that's being used. That is the CyberRange, has over 1,000 users on it actively and brings in around $90,000 to $100,000 every month. So it's an actual thing we're going to be architecting that you can put in your portfolio. I'm going to be breaking down and discussing the architectural decisions I made behind it, not just from like a security and technical standpoint, but from a business use case as well as a systems design standpoint as well. So you can kind of see how these things come together in the real world. So like I said, this is more than just like a random project to go on your resume. It's an actual revenue generating platform that helped me win school games of Q1 this year, if you know what that is. So if you're interested in becoming a security architect or a cybersecurity engineer in the future, this video is definitely for you. So the thing we're going to be architecting, it's called the CyberRange, and it's basically mimics a real life work environment. It has actual enterprise security tools on it with a security stack. And the whole purpose of it is to give people like a realistic place to practice various security operations like threat hunting, incident response, vulnerability management, among other things. I was the sole architect and engineer behind the whole thing. Like I designed it, picked out all the tooling, built the automation and maintained it. But now I'm kind of handing off a lot of those tasks to my staff members. And just a quick disclaimer, the thing that we're going to be architecting, although it is an actual real product, I don't want you to watch this video with the sense of like, I'm going to like build this and then I'm also going to make a lot of money. Like even if you make it perfectly or even better than I made it, you still have to worry about like all those business stuff, like marketing and like sales and like customer relation and like building public trust and all of that stuff. So my intent with this video is not to be like, look, you can like build this too and get money. It's more so you build like a really high-end S-tier project for your resume to show that you have architecting and engineering experience, and then it will kind of give you some context to how it works in the real world, and it will give you a really strong talking point when you get to your interview. And I do want to say, if you do end up building it and you want to actually get users and like manage the users and everything, that will give you a lot of experience and it will be really useful. So if you do happen to build it and you want to get some users, like I wouldn't worry about like trying to make money from them. It just gives you a lot of experience if the users are actually using your product. So if you're wondering where to get users, like you can always join the free cyber community, and there's like maybe 4,000 people or something in there now. So if you happen to build this thing that we're going to architect today, you can always go to that community and ask some people if they want to like try it out for free. And I'm sure some people will at least, and it will help you a lot in terms of resume and interviewing and that kind of stuff. So hopping right in, the goal is to design a hyper realistic work environment using enterprise grade infrastructure and licensed security tools, including a Microsoft Azure tenant, which is going to be our cloud platform that we put everything on. We're going to be using Azure virtual machines. We're going to be using a SIEM, which is called Microsoft Sentinel, Microsoft Defender for Endpoint, which is our EDR or Endpoint Detection and Response platform. And we're also going to be using Tenable as our vulnerability management platform. All of these things will come together and form an actual realistic work environment, which will be intentionally exposed to the internet and will be constantly getting attacked by bad actors, where our users can then use those licensed security tools to practice various security operations like incident response, threat detection, vulnerability management, etc. A lot of stuff needs to be taken into consideration. For example, like the CyberRange, it's intentionally exposed to attack, but we don't want people like when they breach it, we don't want them to weaponize the CyberRange and then use it to attack like outside organizations. And we also need to make sure that the internal users can't like mess each other's stuff up too much. So we need to be really careful with permissions and like the network design and all of that stuff, which we're going to cover. And just to give you a stronger context of what exactly we're building, I'm going to cover the life cycle of a user that's using the platform. So basically the user will pay when they sign up. They'll automatically have their accounts provisioned and they'll be granted access to both Azure as well as Tenable, the vulnerability management platform. And then while they're a member, they'll be able to use the environment to practice vulnerability management, threat hunting, security operations, incident response, and other various security skills with near admin access. Because remember, it's like a live work environment with tons of organic logs and attack traffic. Maybe the user stays for a few months and they pay every month because it's like a subscription-based service. And then when they're done, maybe they get a job or something like this, then they decide to cancel their subscription. Their access should be automatically removed at the end of their billing cycle. And that's basically the product we're making. And before we get started, I just need to make the important distinction between architecting and engineering. So the architect is responsible for defining those high-level requirements and guidelines for the product or system. Like it needs to be like this, it needs to have this, like these permissions need to be in place, etc. Like a kind of high-level design. And the engineer's job is to take those high-level requirements and translate them into concrete technical solutions. So the engineer will take that architecture document, or whatever you want to call it, and they'll bring it into reality. They'll actually implement the stuff. So architecting, high-level design, and then engineering is actually doing the thing and making it happen. And in order to do proper architecting, you kind of have to know about a lot of stuff. Like you have to have a nice broad knowledge, because if you don't know about something, you have no chance to know like if or when to use it, right? And that's one of the reasons why a lot of architecture positions kind of pay a lot, and they're kind of like high-level positions because they just require you to like know a lot of stuff. If you're brand new and you don't know anything about cloud or anything, a really good certification to get that would help you understand what we're going to be doing in this video would be AZ-104, which I believe is Azure System Admin or something like this, or Azure Administrator. But you don't need that to watch this video. You can just watch it and I'll explain everything as we go along. So in this video, again, we're going to be architecting the entire cyber range. And I'll put links for every single thing we talk about, like every platform and technology we'll talk about. I'll put a link in the description or something like this. And it should be enough for you to actually engineer the product we're designing in this video on your own. You'll just have to do a bit more homework, right? Or you can just join the cyber range and there'll be like a similar walkthrough like this, like a video walkthrough inside of there if you want to have like a kind of hand-holding experience. But otherwise, I'll put links for every single thing we talk about in the description. Again, it's designed to simulate a work environment, but I wanted it to be like simple to set up. And I also wanted the network to be flat. Like I didn't want to segment stuff and like secure the network internally a lot, because it's designed to be breached by actual bad actors. And when they get into the cyber range, like after they breach it, it's designed to allow the bad actors to move laterally among the different virtual machines inside the cyber range. The whole point of this is to generate organic attack traffic logs and like organic lateral movement that the members can threat hunt against and kind of observe and create SIM alert rules around. So some key characteristics, it's a shared environment, right? Like 1,000 users are using the same environment. And the whole purpose of this is when the cyber range actually gets breached, because it's designed to be breached, it'll get breached and then the bad actors will move laterally or do whatever they're going to do inside the network. And because it's a shared environment, it allows the members to kind of collaborate on the threat hunts and work together to figure out like the initial attack vector and like work their way through the kill chain to figure out exactly what the bad actor did. And the system needs to have a tightly controlled egress, which means the inbound to the cyber range is basically wide open. Like any traffic from anywhere on the public internet can come inbound. Like they can try to log into the virtual machines and like do whatever they want. But egress, that is traffic from the cyber range outbound, needs to be tightly controlled in order to prevent weaponization of the cyber range. So what this means and what this looks like is, say the cyber range gets breached and like some bad actor from like China or the Netherlands is inside a virtual machine inside the cyber range. If we tightly control egress, when they try to like launch attacks outbound from the cyber range, if egress is tightly controlled, that outbound traffic will be blocked and they won't be able to weaponize the cyber range. So that's something that needs to be put in place. And then in terms of member access control, the individual members need to have administrative access over their own stuff. So for example, they should be able to create their own virtual machine and their own cloud firewall, aka network security group, and configure inbound and outbound rules however they want, delete their virtual machine, do all of that stuff. They have full admin access over it, but the users shouldn't be allowed to mess with other people's virtual machines and resources. At least they shouldn't be able to change them. So that's like a high level architectural requirement in terms of user access control. And then vulnerability scanning, a tenable scan engine needs to be deployed within the cyber range private virtual network. This scan engine will be used by the users to scan virtual machines for vulnerabilities and whatnot. And then all the members should be able to create and manage their own scans. They can like create, change, like update, delete their own scans, and they should only be able to see other members' scans if those members allow them to with their permissions. They shouldn't be able to like delete or change or otherwise mess up other people's vulnerability scans. And then the actual tenable scan engine is the only virtual machine inside of the cyber range that needs to be strongly protected from outbound traffic. There should be basically no traffic allowed inbound to the tenable scan engine. It shouldn't really be accessible from the public internet other than like by admins or something. And then getting into the automation architecture, there's a lot of automation that's happening on the back end of the cyberange. This is necessary to kind of keep the cyberange functioning properly and preventing users from over provisioning resources and basically bankrupting us, right? There's a lot of automation going on the back end. So because of this, we need some code that continuously runs on a schedule on the back end in order to take care of these different maintenance tasks. So to accomplish this, there's like a lot of different ways we could do it. But we're going to use something called an Azure Function App. You can kind of think about it just as like a computer in the cloud with some Python code on it that runs every so often, and you can define the schedule for how often it runs. Within this code, we need to create a few different functions for different maintenance processes. So I'm just going to kind of go over the things that need to be addressed, which the code will handle continuously. So the first thing is resource and virtual machine cleanup. Basically, in Azure, when you create a virtual machine that's just like a computer in the cloud, you'll create the virtual machine and a bunch of other stuff gets created as well. For example, like a virtual NIC, like the disk will get created, a public IP address object gets created, as well as a few other things like a network security group that's like a kind of like a cloud firewall. And sometimes when you delete your virtual machine, that the actual virtual machine will get deleted, but a lot of the other stuff will kind of get left behind, and you can't really expect the user to clean up after themselves. So we're going to define a function that will clean up after users. Like if they delete their virtual machine, it will go through all the users' personal folders or resource groups, as they're called in Azure, and this code or the function will go and like clean up all the leftover orphaned resources. The next functionality that needs to be implemented with code that like runs continuously would be over provisioning control. This just means we need to be able to prevent people from making like an unlimited number of virtual machines, because just like in your house with electricity, the more cloud resources you use, the more it costs. Like the more virtual machines you create, the more it costs. And there's a lot of different ways to control like how many of something that people can create in the cloud. Because remember, the environment we're creating, it's like a realistic work environment, and people are allowed to create their own resources and their own virtual machines. But we don't want one person to create like 100 virtual machines, right? Because that's going to be like really, really expensive. And there's different ways to control this, but the easiest way that I found was to just have some code running that will check everybody's personal folder, and if they have more than one virtual machine, just purge the folder or like delete all the virtual machines. And of course, we're going to let our users know about this ahead of time so they don't get surprised when their stuff gets deleted. But we need some way to control it so people just don't make like 100 virtual machines, right? Because that's quite expensive. The next thing we need our automation code to do is clean up Tenable scans. So Tenable, it's just like a vulnerability management platform. And when you scan a computer for vulnerabilities, what's called a scan will be created. And you can just create these indefinitely, right? And normally with Tenable, you're not going to have like 1,000 admins, right? Because the cyberange currently has like 1,000 users in it. And I don't want a bunch of resources getting created in there and just having them indefinitely get created. And you can't really rely on the individual user to clean up their stuff, right? So to prevent the scans from just tons of scans being created, we need to create some kind of cleanup functionality that will use the Tenable API and look in Tenable and then delete the oldest like X number of scans to just make sure the scan count stays low, because I don't know like how many like scans you're allowed to create in Tenable. So we just need to create some functionality that will go in and clean up the oldest ones every so often. So the next thing that our automation needs to do is be able to regularly clean up Tenable assets. An asset is just like a computer. So when you're inside Tenable, the vulnerability management platform, if you scan a computer, like you scan any IP address, that will like eat up a license. And with Tenable, for about, I think 150 licenses is like something like $8,000 per year if you like legit license it, like not the free version. That's what ours we pay like 8,000 or so for 150 licenses, and there's 1,000 users, right? And you can imagine the licenses will get eaten up immediately, right? But because our environment is kind of ephemeral, that is, all the computers that are being scanned, like they will get deleted, and then the student will like recreate a virtual machine and they'll scan it again. And it's not like the same virtual machine exists forever, right? So we need to be able to free up licenses, because otherwise the licenses will get eaten up right away. So we need to create some kind of automation that will delete the oldest X number of virtual machines like every day, for instance, just in order to keep like our license utilization low. Otherwise, we'll just immediately get eaten up. So this one, just keeping our license count low and deleting the old assets inside of Tenable. To help you like understand this a bit more, basically, like when you scan something in Tenable, you scan a computer, like right when you scan it, that computer like becomes an asset inside of Tenable. And then the only way to get rid of it is to like delete it with the API. And then once you do that, it kind of frees up a license, if that makes sense. So it's just another thing we have to address. And then finally, the last thing, and arguably the most important, is something to handle automatic user account provisioning. So for example, when somebody signs up on our platform, like in my case, like the school.com CyberRange community, they should be able to automatically have their account created. It will create their account in Azure, it will create their account in Tenable, and then it will create like their username and password, and then email their login credentials directly to their school email address, like the email address they use to sign up with school. And then likewise, after they use the CyberRange for X months, they get a job or whatever, and they stop using it, they unsubscribe, it should automatically like remove their access, like remove their Azure access, remove their Tenable account, and just kind of clean everything up. So we need to have like this whole user account provisioning and deprovisioning code running in the Azure function as well. Otherwise, we just have to do like a ton of manual labor. Like when somebody joins, we would have to like manually create their account and like all this stuff, and that's a nightmare. So we want to make sure all that can be handled automatically. So remember, we're talking about architecting right now. So we're talking about things that like are really high level, like what needs to happen in the business use case and that type of stuff. So we're architecting. And then when we go to engineer it, that's when we'll like write the actual code and implement the things, and we can see the source and like see all of this stuff working. So just FYI. And then the engineering part, again, that will be inside the CyberRange, but I'll put everything that you need to know inside the architectural document in the description for this video. So don't forget to check that out. And then that's it for the automation overview section. And there's one last thing I want to talk about before we get into the actual security architecture overview, because we're still in like the general architecture overview. But I just want to talk about quotas really quick. Basically, a quota in Azure or any cloud platform, I guess, is kind of a limit like set on your subscription. So for example, public IP addresses, like originally, like if you don't expand it, you're only allowed to have 20 public IP addresses, for example, and like 20 virtual machines of any given size, and like maybe 20 virtual CPUs or something. And if you plan to have hundreds or like over 1,000 users, you have to do what's called expanding the quota. So because for me, I had a lot of users, I just worked with Microsoft to like expand the quota. And it's relatively simple to do, but it's just something that you have to consider, because you don't want to like prepare the platform and everything and then like launch it and get a bunch of customers, and then you just like hit the quota limit for public IP addresses for your virtual machines, and like no more than 20 people can have a VM. So that's just something to keep in mind depending on like how many users you plan to have. So that's the end of the general architecture overview. Now we're going to actually get into the security architecture of the CyberRange and talk about a bunch of stuff. But the first thing I want to talk about is the CyberRange is designed to be breached, like not the whole thing, but just part of it. So in a lot of cloud platforms and systems in general, you'll have two different, I guess, areas of access, one being the management plane and then one being the data plane. And the management plane is where you would like log in to do things like configure the environment, create resources, and you basically, like if you log into the management plane as an admin, you have like administrator access over everything. You can control how stuff is made at the highest level. And then the data plane section is actually the level where the actual work happens. For example, logging into a virtual machine itself would be like the data plane, and then sending traffic and bypassing a firewall or something. The firewall is considered the data plane, but the management plane would be like the actual Azure portal where you create the virtual machines and you create and configure the firewall. So they're like two different things. And with the CyberRange is designed to be breached, but only on certain portions of the data plane. Specifically, like the virtual machines that are publicly exposed to the internet, and then the network security groups, aka the firewalls, those two things are designed to be breached. But the management plane, like actually logging into the Azure tenant and the subscription, and like logging into the Tenable cloud portal and the vulnerability scanner, those things are not supposed to be breached. Specifically, the management plane needs to be really, really secure. This reflects a core principle of cloud security. Like if part of the data plane gets breached, the attackers or whoever breached it must never be able to access the management plane. Because if somebody has admin access to the management plane, they can just create a 125K a month virtual machine and just use that to crypto mine, and I'll just go bankrupt, right? And then they'll make like, $5,000 in cryptocurrency, but it doesn't matter to them because they don't have to pay the bill. So I just want to iterate that fact, or talk about like data plane and management plane. Part of the data plane is designed to be breached, but the management plane, like Azure itself, like the portal, that should never be breached and needs to be very strongly secured. And again, it's also important to understand that admin access over the management plane inherently gives you full access to the data plane. In most cases, there could be some granularity, but if you get like global administrator in Azure or the equivalent in AWS, for example, you just have access to like everything underneath. But if you happen to like pop a virtual machine, like you get root or admin access to one of the virtual machines, like typically your access, like the hacker's access, is contained to that virtual machine until they make like a lateral movement and start compromising other virtual machines in the cyber range, which happens a lot, and it's designed to happen because it's supposed to make like a real environment for people to do threat hunting in. So management plane, data plane. Management plane needs to be super, super secure. Data plane needs to be, it's open, but it needs to be controlled. So continuing with the security architecture overview, we're going to talk about threat modeling next. Threat modeling is just the process to identify, analyze, and mitigate any threats kind of specific to your platform. And there's a lot of different industry standard, frameworks. For example, like Stride, Dread, Pasta, and some other ones. You can just see what Stride stands for. It's like spoofing, tampering, repudiation, info disclosure, denial of service, and then escalation of privilege or elevation of privilege, however you want to say that. In my case, when I was threat modeling the cyber range, I used Stride just to identify general threat categories that pertain to those 6 areas, as well as like a specific, like an environment specific threat modeling where I just kind of thought of what would be an attack vector or what is a threat like specific to our implementation. So you can just kind of look at this Stride table here. I'm not going to read the whole thing out. It's just going to make the video like pretty long, but you can kind of read through these, like for example, denial of service, like Azure or Tenable hitting resource limits, for example, which this actually happened, right? We hit like a few resource limits on various things that I didn't think about, and it prevented people from being able to use the service like any further. So it's like a legit thing, right? And then in addition to the standardized framework, I assessed environment specific threats that might arise from our unique configuration, operational choices, or like the need for realism in the cyber range. So this is pretty much what I came up with in terms of like environment specific threats for the cyber range. So for example, like the first one, Microsoft disables the subscription due to breach or policy violation, which this happened twice. I'm just gonna like be transparent about that. I won't talk about it too much. I made a whole video about it, but the cyber range got breached. The data plane got breached once, which is by design, but they actually weaponized the cyber range and started attacking big companies from the cyber range. And then Microsoft shut down the subscription, which is a disaster. And this happened twice. It shouldn't have happened 2 times, but it did. So that is a legit risk. Another one, Azure resource quota exhaustion. So for example, we created too many public IP addresses, like too many virtual machines, and then we hit our quota and couldn't create any more. This did happen in real life. So that's like a real threat or a real risk, I guess. Tenable user or scan limits exceeded. So Tenable is a vulnerability scanner, and it's not documented like how many users you can have and how many concurrent scans you can have or how many scans can exist. That's not documented, and I'm not trying to find out the limit, which is why we have that automation function in place to kind of clean up the old scans and like the old resources. Misconfigured user roles with excessive permissions. So for example, if cyber range users accidentally get contributor over the subscription, which is like, that means like admin basically, that's bad, right? Because it means they can essentially bring the cyber range down. That's like a risk. Resource over provisioning leading to cost spikes. So for example, if the user automation, or rather our backend automation that cleans up resources is not functioning right, people will just be allowed to create almost infinite VMs, or at least until the quota gets hit, which is like 1,000 VMs or something. So if the automation breaks, people can just go crazy with creating resources, and that will make us have $0 essentially. And then identity compromise leading to management plane access. So for example, like my account gets compromised, like the only way this would really happen, because we have MFA, is if my laptop gets stolen or one of my staff's laptops gets stolen, and then the Azure token is active on it, then that hacker or whoever stole the laptop can just like do whatever they want essentially until I notice like what happened. So these are some of the like really environment specific risks that I identified. So we're still in the security architecture and overview phase, and we're going to talk about IAM, that is identity and access management. So I'll just kind of go down the list of considerations, like IAM specific considerations. So MFA should be enabled and in place and enforced for users within the Azure subscription. It's required, they just need to use it because all the CyberRange members have some level of management plane access, right? They can log into the portal and create resources and like all that. So that needs to be protected with MFA. And then role-based access control with least privilege needs to be in place for the individual CyberRange users, that is the customers. So basically what this means is like all the users should have near admin access to the stuff that they need to use the CyberRange properly. So this would mean like admin access over their personal virtual machines, ability to create storage accounts and create their own firewalls, which is called a network security group in Azure. They need near admin access to be able to do all of that stuff, as well as in Tenable as well, right? But they shouldn't be able to affect other users' resources and resource groups, like in their cloud folder. You can kind of think about a resource group like a cloud folder. All the users should have admin access over their own stuff, but not be able to affect other people. So access controls need to be in place to allow that. And then service account and automation needs to be considered. So remember, we have a Azure function running. There's code running that does various maintenance tasks. And some of those tasks include deleting virtual machines. Like if somebody goes over their quota, they create too many, as well as like deleting other random resources in Azure, as well as cleaning up stuff inside Tenable, like deleting assets, deleting scans, and etc. So that account, like that code that's running, that's deleting all that stuff and doing all those maintenance, that thing needs to have controlled permissions as well, because the code can't just like run and be able to do that stuff, right? We have to kind of tie an identity to the function that's running that code that allows it to do what it needs to do. So that the permissions for that account need to be scoped down appropriately, and it needs to have like minimum access in order to like do its job, right? So that needs to be considered. That thing shouldn't have like global access or global admin access, because if that's the case and it gets compromised, people can just do whatever they want with it. So least privilege needs to be in place for the automation for the Azure function app is what I'm trying to say. And then the final section in the security architecture overview, this is just going to be really quick. It's just a high level architecture security mapping summary. It just has like the system component on one side and then the security controls applied on the other side. This is all stuff that we just talked about. It's just kind of summarized into a big table. So you can look at Azure Management Plane, that just means the Azure portal, and then the security controls that are applied to it. So MFA, role-based access control, scoped accounts, their permission is scoped down, and then logging and log ingestion into Sentinel. And then I won't read the rest of these. You can just kind of eyeball them because it's something we just talked about, but it's just a summary of all the security controls under the security architecture overview section. And this section is going to be pretty quick. This is the data protection and privacy controls. There's not a lot of data that's stored in the CyberRange. It's not like people have personal documents and there's no intellectual property in there. It's just a large environment with a lot of users and organic logs. But I do want to try to protect users' information, or at least their privacy a bit, by kind of obfuscating their username. So in order to do this, instead of using like your personal email or allowing them to create their own usernames like Cindy Lou or like Josh Madakor or something like this, basically their username is going to be created for them, and it's going to be based off of their school.com email address, like the email address that they signed up with. So I recommend, or what I did anyway, is I took their email address and then I just hashed it with SHA-256. Best practice would be to salt and then hash this. You can kind of look up what salting means, but We're going to create their usernames for them based on their original email address. So when they log in and use the cyber they're going to have this like really long hash for their username, and then whatever password they happen to get assigned or make for themselves. The reason for this is because when you log into Azure and you do various stuff, in the logs, it will show like your username, and it will show like your public IP address and your geolocation, like in Toronto, Canada, and like whatever your IP address is. And it's really easy for other CyberRange members, which is like hundreds of users, to just like look at that and correlate information, and they can derive things about you that maybe you don't want people to know. So it's a SOC, right? It's a live like security operations center with a proper enterprise security stack. So all that stuff is just being logged, and it's easy to correlate. So in order to like help with privacy, we're going to obfuscate usernames. So when the user account is created, instead of letting the user create it or using their original email address, we're going to hash it and then use the hash as the username, just to kind of help with privacy a bit. So next, we're going to talk about monitoring, logging, and incident response. So log, scope, and retention. The CyberRange should implement log retention policies. So both for the management plane and the firewall logs. Management plane, that just means doing anything inside of the Azure portal, like creating virtual machines, like deleting a virtual machine, creating a firewall, changing a firewall, turning a virtual machine on. All of that stuff needs to be logged for at least 30 days, as well as the firewall logs as well. So when traffic comes into the CyberRange, regardless of what happens, if it gets dropped or allowed, etc., or whatever, all those stuff needs to be logged for at least 30 days. And then virtual machine logs need to be captured as well. This will happen via the EDR platform, which is Defender for Endpoint. Basically, this includes like all processes. So a process is started, registry change happens, some stuff happens in the file system, like a file is created or deleted, logon activity, someone attempts to log into a virtual machine, whether or not it succeeds, that should be logged as well. And then network telemetry from each endpoint needs to be logged as well. And then getting into the log aggregation architecture, like where logs are stored and routed. So virtual machines, all of this will be stored in the Microsoft Defender for Endpoint portal, I guess you can think about it like that. And then some of those logs will be forwarded to what's called a log analytics workspace, which is our central log repository. And then the log analytics workspace will be connected to Microsoft Sentinel, which is the SIM. And then the SIM, we're able to like look at all the different logs, as well as create what's called analytics rules, which is an alert. So if certain combination of logs appears, or like any kind of log that looks suspicious, we can define that. We have the option to automatically create an incident or create an alert, and then have the student be able to work that alert or work that incident to completion. And this is something that the CyberRange members can do themselves. This is a diagram of what our logging looks like. This blue portion here, this is from all of the virtual machines, MDE, Microsoft Defender for Endpoint. So when we install the EDR agent on the virtual machines, these logs are like automatically captured and stored in Defender for Endpoint, and then we're forwarding a select few of them to our log analytics workspace, which is our central log repository. And then Entra ID, this used to be called Azure Active Directory. We have audit logs and sign-in logs. These need to be enabled. Audit log is just when you like create a user account or assign some kind of permissions to a user or delete a user, something like this, that gets stored in the audit log. And then sign-in logs is when somebody attempts to authenticate against Azure. Whether or not they succeed, those logs will be stored in the sign-in logs. And then we have Azure data plane and management plane logs. So this is basically just is like if you create or delete or change resources in the Azure portal, those will actually get logged and then sent to Log Analytics Workspace. And then the data plane logs, this just includes normally like the virtual machine logs would be part of this, but those are being handled by Defender for Endpoint. So the other data plane logs that need to be handled are the actual firewall logs or the network security group logs. So traffic coming into and going out of the CyberRange, all of those, like whether or not they're filtered or allowed, etc., all those logs will be sent to our log analytics workspace. As far as incident response integration, Microsoft Defender for Endpoint, which is the EDR solution, this should be auto-provisioned, which means when a virtual machine is created and it's on for a certain amount of time, it needs to be automatically onboarded to the Defender for Endpoint or the EDR platform without the user having to do it. And the point of this, like once it's onboarded, all the telemetry on the virtual machine is automatically captured and stored in Defender for Endpoint for 30 days. So all of those like file system changes, registry changes, process events, device logon events, all that stuff should be like automatically captured because the virtual machines need to be automatically provisioned and onboarded to the EDR platform. So again, touching on the security control philosophy a bit, the cyber is intentionally designed to be really, really realistic and simulate a real world environment. In fact, well, I'm speaking in terms of like the present time. It is a real world actual environment with a lot of users on it. So it's built with a lot of leeway, or we're architecting it with a lot of leeway in place to allow people to do stuff that they need to do. And of course, there's that like Venn diagram or whatever, like the more functionality you have, like the less secure it is, right? And this is intentional. So like we talked about, we have to secure the data plane, certain parts of it, but we really need to secure the management plane. Part of the data plane is like intentionally intended to be breached, but it's just something we're acknowledging ahead of time in the architecture phase. Like there is some risks we're taking on because the environment is realistic and people need to be able to like do enough stuff. But the byproduct of that is it's possible to mess with other people's stuff to some extent. But as long as we're like anticipating it and it's intentional, it becomes kind of less of a surprise when it actually happens in real life. So getting into business continuity and disaster recovery, our recovery objectives. So recovery time objective, which is RTO, which is something you learn about in CISSP and maybe even like maybe Security Plus, I don't know. But recovery time objective, this just means like how long it should take rather to recover the system if it goes down, like whatever that means. Like if it gets brought offline for some reason, we're defining the RTO as 24 hours. And you can just like make this up for your environment, right? You know, if you're Amazon, the RTO should be like, 1 minute or, 1 second or something like this, because if Amazon goes down for like a day, that's like tens of millions of dollars, down the hole, if not more, right? But for us, it's just a training platform. So RTO of 24 hours makes enough sense for me. And then RPO, like recovery point objective. RPO is like how far back of data you need to be able to recover if your thing like goes down. For example, if we have some important data, and we have an RPO of 1 hour, it means like from the time it went down, we should be able to recover everything up to like an hour before the actual system went down. But we don't have an RPO because there's no like IP or anything actually like existing in the cyber range. So it's not really applicable. And the virtual machines, the argument could be made like we have to preserve those, but like not really, because they're intended to be ephemeral. They're just something that you can scan and practice like security operations against, and people are not supposed to be storing stuff on the actual virtual machine. So like RPO is not really applicable for the cyber range. And then in terms of like a backup strategy, again, there's nothing really to be backed up. It might be a good idea to export the users from Active Directory, aka Entra ID, just to do it every so often. But this is not really like a big deal. It's not something that's required because all the user data is actually stored, in my case, it's stored in the school platform, right? We're just kind of like creating accounts for those people in the cyber range. And then as far as disaster recovery goes, I personally, like as long as the cyber range and everything is like really well documented and you're able to spin it up relatively easy from your documentation, there's not really any need for like a hot site or a warm site. You'll learn about like cold site, hot site, warm site, etc. in Security Plus. Like a hot site just means there's like a legit like secondary cyber range like on standby with like all the infrastructure there already. But that will cost, it's pretty expensive, right? Because it means that stuff is just like running, waiting for the first cyber range to go offline and we migrate people there. But if everything is like really well documented, there's not really any need for a hot site. I would say like I didn't even make any kind of like disaster recovery site, but it might be worth, if you want to practice, it might be worth creating a warm site. Like just create all the, like mirror all the architecture and stuff on like a second Azure tenant or subscription, and then set up all the stuff that actually doesn't cost money to run, if that makes sense. But I don't personally do this because Everything is documented so well. If it goes down, I can just rebuild it, probably in like 24 hours or less. But I just wanted to talk about disaster recovery a bit as well. And documentation and recovery readiness, a complete and current architecture plus implementation document will be maintained to support disaster recovery efforts. So this architecture document, as well as the engineering document, like how to actually like set up the stuff, should be well maintained, and you should have it, if you plan to use this as an actual like product that makes money. So this document basically serves as the blueprint for rehydrating the environment and should be reviewed and updated quarterly or after any major system change. So if you're going to make a product out of this, you might want to maintain your architecture and engineering document, just in the case of something goes down and you need to rebuild the cyber range ASAP. So next, we're going to talk about pricing. That is how much we are going to charge the users per month to actually use the platform, the cyber range. And a good place to start on this would be just to figure out roughly how much the expenses are going to be per user. And then you can kind of use that as a starting place to kind of think about how much to charge people per month. Of course, that you can work in like yearly deals and like all the stuff, but just generally speaking per month. So there's 4 major things that cost money inside of the cyber range. The first one being like the actual virtual machine will cost money to run. Sentinel, the SIM, will cost money to run based on how many logs are ingested into it. Defender for Endpoint, that's the endpoint detection and response platform, or the EDR platform, that costs money per virtual machine. And then Tenable, the vulnerability management platform, also costs money. That the licensing for that is different, but it costs money like every year depending on how many computers you have in your license, right? Breaking these things down, I'm going to talk about virtual machines first. So this is something you would probably like research in the architecture phase, which is what we're doing right now. So if you go to Azure and then you try to create a virtual machine as an admin, and you choose different virtual machine sizes, like how much RAM and CPU, etc. it has, you can kind of see how much it will cost per month based on what you select. So this is the virtual machine I ended up using for the cyber range, but this particular one has a single virtual CPU, 3.5 gigabytes of RAM, and it costs $46.80 per month, assuming it's running 24 hours, right? So that's $46.80. And then the next thing, that's the EDR platform, Microsoft Defender for Endpoint. This will cost in Azure $15 per month, assuming for every single virtual machine, it will cost another $15 per month, assuming the virtual machine runs like 24 hours per day, 7 days a week. That's like the price for it. And it's by hour, I believe. So that's something to consider. And then think about Microsoft Sentinel. This is our SIM. And this is based on log ingestion. So depending on the region you're in, like a single gigabyte is $5.22. And we're not really ingesting that many logs, really, to be honest. So we can kind of estimate this as going to be around maybe like $1 per month is fair. It might even be slightly less than that. And then finally, Tenable vulnerability management. If you're doing this for yourself, you're just making a project, you don't have to license like the full-blown Tenable because it's quite expensive, right? You can get like the free version or like a trial or something like this, but Tenable's pretty expensive. For me, it was about $8,000 per year for 150 users. And if you break this down per monthly, assume 150 users, that's about another $4.50 per month per user, assuming you have 150 users, right? So using the previous information that we gathered up, with the virtual machines, the EDR cost, Sentinel cost, and the Tenable cost, assuming the user provisions a virtual machine and leaves the VM running like 24 hours, the maximum cost per month will be $67.30 per user, like the max cost, like about $68 per month, right? It's kind of good. It will give you like a good idea, I guess, or a good starting point. But if you think about if the person doesn't like create any virtual machine, they're just a member existing per month, they will end up costing only about $4.50 per month because of the assumed Tenable license, right? No VM usage, no Defender for Endpoint, no Sentinel logs. It'll be about $4.50 per month. And if we want to think about a realistic scenario, where a user is using it, but they're only studying like 2 hours per day every single day. This will end up costing about $3.90 per the virtual machine because they only have it on 2 hours per day, about $1.25 for Defender for Endpoint, because again, that's $15 a month, assuming 24 hours usage. And Sentinel, that'll be about 8 cents. It's going to be insignificant. And then Tenable, it will be about $4, again, $4.50 per month, assuming 150 users, all those licensing costs divided up. So we have our maximum estimate of about $67.30 per month. Minimum cost per user is $4.50 per month. And then our realistic estimation is about $9.73 per month per user. So that's a really good starting point. If we're trying to like figure out how much our platform costs, we can kind of guess on how much we want to charge the users. And remember, this is like raw cloud expenditure. This doesn't account for our maintenance costs. Like we have to fix something, we have to set up all the automation, like all this like support and like all the other stuff. This is just raw like cloud expenditure. So it would be probably a bad idea to charge users like only $50 a month, right? Because theoretically it's possible for them to like overspend their own subscription cost. So like spoiler alert, like I ended up charging $97 a month for the CyberRange, or like rather, well, I could talk about this a lot, but currently it's $97 per month, which is actually like a pretty, if I'm not wanting to be greedy, it's like a pretty decent price point because it gives some leeway, right? And it should have a pretty healthy profit margin, assuming the average user only ends up spending like $9.73 per month. So this is the whole cybersecurity architecture guide. I'll put a link in the description with the actual architecture document. And inside of that document, I'll put links to absolutely every single technology that I talked about. So you can try to work to build the environment on your own. Like you create your Azure account and you set up your subscription, and then you build out the network, like the virtual networks and the subnets and the network security group, and you set up the firewall rules as we discussed in the architecture document, and you do all the stuff. It's possible to do that on your own, like with the documentation I provide. It'll just take you some time to do to like figure it out and everything. But if you want to actually have your hand held and we build the whole CyberRange from start to end, you can join the actual CyberRange, and there'll be like a module inside that shows you how to do that. But if you want to, in the meantime, I recommend joining the cyber community. And if you want to try to set it up on your own, the cyber community is free. And if you get stuck in there, you can always like make a post and tell people what you're doing and like where you're stuck, and then maybe they will like try to help you through it and stuff like this. You can also always DM me personally in the cyber community. I respond to all my DMs in there. That's why I really laser focus my attention. But yeah, hope this was fun and interesting for you. It's definitely like a super hyper S tier project. And if you get to the point where you can build the CyberRange and tear it down and build it again and tear it down and build it again, it's going to be like a really, really strong talking point for you when you get to an interview, especially if you get actual users using the CyberRange. Like you ask some people in the free community to try it out for you, and then of course, this will cost you money to do, right? But it'll be really minimal, assuming you put the necessary controls in place to prevent people from like spending $1 million. It should be minimal cost for you, but it's like a really, really strong for your resume. And again, if you frame this inside of an LLC and like as an actual product, it's just like, you're going to be really strong. So highly recommend it. And of course, if you want to join the actual CyberRange as a member, like either you want to actually get into cybersecurity because we have like those whole like vulnerability management and threat hunting, security operations stuff, as well as like an actual internship. And that legit works because people are actually getting jobs for this. I have someone dedicated to providing those employment verification for when companies reach out, and just I record whenever somebody gets a job, and it's pretty often. I might put a link in the description that shows all the people who've gotten jobs, but it works really well. So if you want to get into cybersecurity, you can check out the CyberRange, or if you just want to see what the user experience is like in the CyberRange as an actual user because you want to build it, feel free to join that as well. But either way, feel free to join the free community, and you can DM me and like make posts, and it's just like a really constructive environment. So check that out, and hope you enjoyed this video, and we will see you in the next one.